Looks like we have viewers. Welcome to DECIDEthoughts' first episode. I am your host today, John Heemeyer. Today can be considered a special treat for some of our followers who have been with us from the start. A while ago, we asked our followers what they'd like to see an episode on and gave them a few choices. This is the subject that won. The Positional Value Interval System, or what we call the PVI system, is a new Decide original concept. It is a numbering system that does not use a base like all other numbering systems we've come across. Well, we'll get to the PVI system shortly. Some people may not know what we mean by a base numbering system. If you do already know, feel free to skip ahead to the timestamp provided. There are a small handful of variations of base numbering systems. Let's go over each of these. For simplicity's sake, we will only take a look at one instance of each. For a clearer list of various numbering systems, go to the link provided. All links will be shared in our descriptions as well. Binary, trinary, octal, decimal, hexadecimal, and many others. Whatever base is being used, once it passes the numeral of its limit, i.e. binary has 0 and 1, its limit being 1, whereas decimal has 0 through 9, with 9 as its limit. It adds a new digit that has a value of 1. For instance, new digit value 1. This is multiplied by the base raised to the power of its position. For instance, the first position in a decimal number is multiplied by 10 raised to the power of 0, which equals a multiplier of 1. The second position is 10 raised to the power of 1. Which means its multiplier is 10 in value. This digit increases again by 1 in the numeral sequence each time the previous digit passes the base limiter, creating a new digit when it too passes the base limiter. Next are multi-base systems. A handful of these exist. Basically, these systems have 2 or more bases. The first digit is the first base, goes to its limit, then the new digit is the second base up to its limit. Once each base in the system has been represented, it goes back to the first base and repeats. Otherwise, these work as single base numeral systems. For example, we'll use a binary decimal. So the first number will have a base 2, and the second number will have a base 10. So if we count, it will go something akin to this. 0, 1, 2, 3, 4, on and on until 19, then 20. This goes on until 39 and continues on from there. Most base systems are considered to be dynamic. This means the explanation previously given is what stands for them. However, there are versions that act differently. These are generally called static numeral systems. These systems can be used single base or multi-base. The most well-known of these systems is the Roman numeral system. Basically, you have a single numeral that stands for 1. Each time you add 1 to it, you just write that numeral again. So 2, 3, 4, until you reach its base limiter, in this case 4. Then when you pass the base limiter, you go to a new numeral, and continuing to add 1 simply adds more until the new limiter is reached. Some of these systems, such as the Roman numeral system, show the base limiter by putting the next numeral up with a lower numeral before it. For example, when we reach 4, instead of it being like this, it shows like that. This literally means 1 before 5. Lastly, we have monary or unary systems. I'm not really sure what the term is for them, but these systems claim to have no base, but are in fact a base 1 system. What this means is that each symbol represents a specific value. And to understand the system, you need to know what each of the symbol's individual values is. These are commonly seen in memes, such as the one I'll put on screen now. While holding little actual usage value due to the inconsistency amongst memes and using different symbols to represent the same numbers, understand that each symbol can appear multiple times, and each symbol's individual value is added together to determine the total value of a symbol collective. Generally, these are separated in memes by mathematical notations, as is shown. Unfortunately, if one symbol present has an unknown or undeterminable value, the total value becomes unknown, making this system infeasible. So we are finally at the positional value interval system. Up until now, each of the numbering systems shown has been a base system, but not one of them requires they declare what the base system they use is in. This means that 101, 101 plus 156 can equal 101, 257, or 201, or many other possibilities. This is because all we know is that 101, 101 is at minimum a base 2 number, and 156 is at minimum a base 7 number due to their highest digits of 1 and 6. But what if both were in base 16? In this case, the answer changes drastically. If we translate the numbers from base 16 to base 10, they become 1,052,929 plus 5,382, which equals a total of 1,058,311. And this problem can cause a fair bit of confusion if you're not using a standardized base system like most countries do. However, with the positional value interval system, this becomes a non-issue. The interval is probably one of the most important parts of the PVI numerals. The interval is effectively one higher than the number of loci, or digits, shown in a PVI numeral, and a PVI numeral before a separator, the comma between numbers. In our version, we use that to denote each loci digit. So, a binal PVI number is as such. A quadernal would look like this, and a decimary look like such. These terms are the interval version of the base equivalent terms. Binal is equivalent to binary, quaternal is quaternary at base 4, and decimary is equivalent to being the decimal system. Each loci has a value assigned to it. Reading as normal, the first number, for English speakers, the upper leftmost, has a value of 1. The next has a value of 2, and so on, until you reach the final loci for the interval. Next is the position. This may confuse some, but we aren't talking about the position of a loci, but rather the position of rotation for a loci. Our version shown here has 21 positions of rotation as shown. Each rotation marks a time the PVI number has had that rotation past the final loci. For instance, if we use a decimary interval, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Now, if we add one more, you'll notice the rotation advanced to the next rotation symbol. From there, we continue on. 11, 12, and so on and so on. We can use this method in any interval system and be able to determine what the number is. Okay, so what if I give you a random PVI number? Let's start easy. Can you tell what the number is? How about a little help? You start by looking for the highest position of rotation and write down the value of that loci as the highest digit in this number. Then you look for the next highest and write down that loci's digit. You repeat this process until you have reached the lowest rotation. If a position of rotation is not found, place a 0 and continue on. If you were successful, you just translated the decimary PVI numeral into the decimal number 825768. Using this method, one can easily translate a PVI numeral into its base system counterpart. Okay, so how about a harder example? This is a quaternary PVI numeral, but what is it in decimal base system? There are two ways to go about this realistically. Either you can translate it straight to a quaternary number. You will get 31002001000010, and then translate that into decimal. Or you could just use the PVI calculation. The PVI calculation is the value of the loci multiplied by the interval of the numeral raised to the power of the position of the rotation. As such, we have P equals 12 with an interval of 4 at value 0.3. Or 50,331,648. Our next number is P equals 11, interval of 4 at V equals 1. Or about 4,194,304. Continue doing this for P at 8 at V equals 2, P of 6 at V equals 1, and finally P equals 2 at V equals 1. Total these all up, and you get 54,661,136 as your final decimal number. So hopefully that wasn't too hard. Now the question becomes, how can this be used to advance our understanding of mathematics? Well, the PVI system has three main benefits. Number one, since in the PVI system the interval is clear immediately, adding two numbers of different intervals is easier to visualize and understand when compared to two equivalent base system numbers. Number two, the PVI system is much more visually oriented, allowing for visual patterns to appear clearer in various numbers which might not be seen using a base system. Not to mention, it is a bit artistic. But considering writing out mathematics specifically, think for a second on the speed of light. The speed of light as it is currently understood is 299,792,458 meters per second. Mathematicians use C as shorthand to write it, which clearly takes much less space than the 299,792,458 normally written for the speed of light. It is visually distinct, and those who understand the system can read the PVI number easily. Even those who can't read it immediately can figure out what the number is. In short, the PVI system can be easily understood regardless of interval, can enhance pattern recognition in numbers, and can be used as a clear and concise shorthand for large numbers, often found in astrophysics and the like. For those who would like to review the subject in a textual format, the link will be provided below. A quick addendum before we close out. Keelan Tolshi brought up a good point. He asked why we used the specific size and shapes which we did. The rotational values which we showed were specifically chosen to fit a font size of 12. In a font size of 12, the rotational values will be distinct enough to be able to differentiate from one another and still readable. However, if we increase the font size to, say, I believe it's 24, we can then add more rotational value, more rotational positions. For instance, we now add in these rotations. That alone is 9 more additional rotations. We can do this for each spot, adding a total of 72 more rotational values to the system. The larger font size that is used, the more rotational positions can be added. So the question remains, is the PVI system worth learning? Well, as with everything in life, that is for you to decide. So the question remains, is the PVI system worth learning? Well, as with everything in life, that is for you to decide.